Hello, everyone. I'm Pierre Le Breton from L'Allemand Animal Nutrition, and very pleased to welcome you on this third video session about digestible carbohydrate strategy for swine. Carbohydrates in swine nutrition are very important, of course. It's kind of obvious. It's one of the main components of diet for swine. It's the basic of the energy component in the swine diet. The digestion of carbohydrates is important on many parameters and will play an important role on the global performance and health of the animal. And we will spend some time also showing that the kinetic of absorption of carbohydrates is more and more central in the strategy for swine nutrition. Carbohydrates are the main component of the swine nutrition. From piglet to growing pigs to sows, we are always and everywhere in the world above 50 to 60% of the global dry matter eaten by the pigs. So it's a very central, let's say, component in this diet. And sometimes, even if it's central, it's a forgotten fraction in the diet, in the strategy, and sometimes we are not accurate enough in the way we are preparing and in the way we are thinking about this carbohydrate, let's say, composition for our swine diets. When it comes to dietary carbohydrates, we are facing globally a large family, a quite complex and large family. And depending on the composition and the structuration in the diet, we will have different physiological impact. Some will be digestible, very fastly digestible. Some will be slowly digestible, and some will not be digestible, possibly fermentable. And because of this, let's say quality, physiologically, we will have different impact. So today, we're gonna focus on the digestible fraction of carbohydrates. And in another following video session, we will spend some time, specific time, on the non-digestible part of the carbohydrates family, focusing on dietary fiber with all the application, positive and negative impact coming from those non-digestible carbohydrates fraction. So today, we focus on this digestible part and mainly on starch and sugar composition. If we just begin with the starch, starch is usually shown as something quite simple, but in reality, it's quite complex. We always have glucose at the basis on those starch, and this glucose will be polymerized into two main components, really different components composed of glucose that are amylose on one hand and amylopectin in the other hand. Amylose will show some small branching when amylopectin is completely branched and much more complex. If we have a microscopic vision of those starches, if we have a view on crude starches, we will see from the microscope some granules, specific granules that, depending on the raw material and depending on the treatment, will have some visible differences in the way they are structured and stored together. And those granules, you will see, play a quite important role on the, let's say, the way the animal will be able to efficiently use and digest those granule content. So we are speaking of two main components for the starch, amylopectin and amylose. Okay, and if you look at different raw material, when it comes to raw material, the relation, the ratio between amylopectin and amylose will be able to drive some specific physiological impact of the raw material coming from these, let's say, mutual composition. And one main, let's say, characteristic that will be driven by this composition between amylose and amylopectin is the kinetic of absorption. So when it comes to barley, wheat, corn, oat, potato, peas, all those raw material we are able to find on the market with high starch content, depending on the amylose and amylopectin content, we may face some differences, physiological differences on the animal. Not the same, let's say, impact, and again, mostly a difference in the speed of the glucose release, in the speed of digestion and absorption. It's always a matter in your raw material, it's a matter of a matrix, 3D matrix. Inside you will find blocklets and granules that are the main, let's say, storage component for the starch in the plant, in the vegetal, and with some protein in between in order to glue everything together. And depending on this complex 3D matrix, the process, when it comes to milling or to the heat treatment that we may have in the factory, those process, we also will play a role in the release of what is inside those blocklets, inside those granules. One word about the technology, and that's part of our job, to be able to prepare the raw material for a better targeted digestion. Of course, when it comes to starch, the particle size strategy is of importance. It is quite strategic, important to be able to be accurate on this particle size strategy. In the past, as you see on the screen, in the past, we were mostly focusing, especially for piglet, on the thinner, the better. Looking for the thinner particle size in order to face the highest digestibility. And we have some nice study showing that as a trend, for every 100 microns lower in the particle size, we were saving almost half a point of digestive coefficient for the energy. Today, okay, it's still true, but in front of this strategy in particle size, we are a little bit changing the strategy in order to also play on the gut microbiota diversity, playing with the kinetic of digestion and not looking to the thinner particle size, especially around the weaning, trying to find a compromise between digestibility and, let's say, gut health. Okay, knowing that the thinner doesn't mean the safer. Another point of, let's say, technology when it comes to starch are all the kind of heat treatment that we may apply on the starch in order, again, to modify the digestibility, especially for young, immature animals. What's happened when we are applying some heat treatment on the starch? As you can see on the screen, when you have, like here, the granules, the blocklets of starch with no treatment, let's say crude, as soon as you begin the process of increasing the temperature, you will break those granules, make them open, release the starch. That can be, again, amylose or amylopectin. And as soon as you open those granules, it's obvious that the enzymatic treatment will be easier, because the capacity to enter the granule and to treat the starch, of course, is facilitated. Okay, but in the same time, we are improving this release of starch. We are also improving the viscosity of the global content. Again, to have some view, a microscopic view, if you compare on the left crude diet, let's say feed with no treatment, to the same feed but treated, we can see that the granule doesn't have the same shape, the same appearance. The heat treatment is able to open those granules. And that's the full picture when it comes to gelatinization. Gelatinization is a level of heat treatment applied to the starch. And again, in the past, we were trying to apply for piglets the highest gelatinization state. We thought it was the better. Today, we are more focusing on the quality of this heat treatment, not looking at the highest level of gelatinization. And as you can see on the screen, if we look at the feed intake, but also the average daily gain, just modifying the level of gelatinization of starch in the piglet diet, we see that as soon as you reach 20% of gelatinization, the benefits of going higher in gelatinization is not that clear, meaning that digestibility will not be higher. The global digestibility will not be higher, and at the opposite, improving the speed of digestion because of high level of gelatinization may also have some negative impact on the performance. Okay, so especially for piglets around weaning, we need some treatment, both particle size and heat treatment. But don't forget that, again, the highest is not the best. The highest is usually not the best. When it comes to piglet after weaning, again, speaking about digestibility, the heat treatment is useful. I'm not saying it's not useful. It is useful, especially for the piglet we are facing today, with a lower weight and most of the time also lower maturity in the digestive capacity of the piglet. And if you see on the screen here, if we compare the same diet but with raw wheat, not treated wheat, compared to extruded wheat with the same particle size, you can see that the digestibility coefficient, especially during those 2 first weeks after weaning, we see a quite important difference in the digestibility coefficient coming from the extruded wheat. But as soon as we reach the 2nd week after the weaning, the maturity of the animal is much higher, much better, more classical, and then the requirement, the need of any treatment on the starch has not the same impact on the animal. Okay, so when it comes to strategy, what do we have in hand? we have the quality of the starch, depending on the quality of the raw material, with different impact on the animal. And we have all the technological treatment that can be, again, particle size and the quality of the heat treatment we may apply. And depending on the composition, the choice you will make on several raw material, then you may have a difference in the composition in your starch degradation kinetic that will come from the addition of every raw material treatment and quality that will compare to the global feed is global impact on the animal. So the starch content, the starch quality, the level of gelatinization, and the particle size applied for every component of the feed will be, in your strategy, your main, let's say, factors that will influence the digestible carbohydrates strategy. And we have some in vitro tests that are able to show, to express the speed of digestion. Englist is one of those. And then you can make a difference between rapidly digested starch to slowly digested starch, or at the extreme, resistant starch that will not be digested by the animal. And coming from the human nutrition, we have also some, let's say, index, like the glycemic index, that will be directly related to this kind of, let's say, description coming from in vitro tests like Englist, and helping us to have this kind of, let's say, index in the description of the glycemic index, so the impact of treated raw material on the glycemia of the animal. Because depending on, let's say, your strategy in those digestible carbohydrates, you may have some impact, important impact, qualitatively important impact on the glycemia of the animal, the glucose content in the blood in the animal, depending on the type of diet. And as you can see from this trial, we may see after a meal, we may see a big difference in the glycemia impact of depending on the type of diet that we will provide to the animal. And that's something that will have an impact also on the behavior of the animal and on the physiology of the animal. So we need to have in mind that the type of starch, the type of treatment, the type, and we will see it later, the way we will control the gut microbiota will modify the glycemia of and the glycemic impact of the diet, and in the same time the insulinemia coming from this type of diet. So we spoke about starches, but just beside starches we also have simple sugars. Okay, and that's much more simple. We have two main categories of simple sugars, the monosaccharide and the disaccharide. Inside the monosaccharide, we have fructose, the sweetest one. We have galactose that usually we will not find naturally in the diet, and we find glucose, dextrose. In the disaccharides, classically, we find lactose, okay, lactose, which is classical sugar in the milk, and so it's composed with galactose and glucose together, and need an enzymatic treatment to be cut and processed. We have the maltose that you will find in, for example, in barley, and we have sucrose that we can find directly, in, for example, in piglet diet, that can be found in sugar beet, sugar cane, this kind of raw material. Some word about the digestion, what happened. So we have a first impact on the mouse, stomach impact, and mostly because here we are speaking about digestible carbohydrates, mostly small intestine. And in this small intestine, we have in the global lumen the hydrolysis that will occur, and we have on top on the epithelial cell, and also on the distal digestion site, we will have this process of digestion. What does it mean? It should be done globally. All this digestive process should be done, is done before the large intestine. Only the resistant starch that are not digestible by definition will be found and may be processed in the large intestine, coming from, let's say, bacterial use. And I will not speak about what happened with non-digestible fraction. We will have a specific session on those, let's say, fiber type. Okay, so the main area where we have this process is the small intestine. If we make a link to the PRISM nutrition description, when it's come to digestible carbohydrates, we have a huge, clear impact on the macronutrition expressed in our matrix in the net energy. Okay, everything related to starch and sugar are directly taken into account in the equation of the net energy. But we should not forget that depending on the choice that you will make on starch quality, starch quantity, and treatment, particle size, heat treatment, we have a big physiological impact. So we also play on the physionutrition. Okay, and then we will have an impact on tissular inflammation, liver efficiency, feeding behavior coming from the satiety control, and the global behavior of the animal. So with digestible carbohydrates, we are playing both on macronutrition and physionutrition. And to be able to have this macronutrition, that could be for starch, but also for disaccharide, we have to help this enzymatic treatment. Okay, for monosaccharide, no enzyme are required, but for disaccharide, for example, lactose is a typical example. You need the lactase to be able to process the lactose and to release the two monosaccharides. And if you don't have the lactase, that this concentration as the production of lactase is decreasing in the life of the animal, and then this lactose will be used by bacteria for fermentation, as an example. Okay, and when it comes to the starchy polysaccharide, the type of amylase, that will not be the same between amylose and amylopectin, and depending on this, the yield of digestion, but also and mostly the speed of this digestion will be different. So at the end of the process of digestion, we will focus on glucose mostly. So glucose is a very important component, And we may stop a bit this presentation focusing on glucose, because this glucose at the end is really affecting the animal. So this glucose will be essential for swine for three main reasons. The first obvious one, it's a direct substrate for energy that will be used, for example, by neurons or a blood corpuscle. That's a first, let's say, first quality. The second one is the way it will be able to create energy reserves in the body coming from this glucose. It can be glycogen, liver, muscle, kidney, but also triglycerides that are involved in the fat storage, triglycerides. And at the end, also the glucose will be involved in the synthesis of glycolipids or glycoprotein. So this glucose is more than important, of course. And more, we are focusing on the impact of glucose as a chemical messenger that will play a really central role in the, let's say, regulation of metabolism, regulation of satiety, or at the opposite, regulation of appetite. So that's why we must really control what is happening around this glucose release, glucose absorption in terms of yield, but also in terms of speed, in order to control what is happening inside our pig. So when it comes to glucose, when the, let's say, digestion is done, we are facing a regulated process of absorption. And this process is regulated first depending on the level of concentration of the glucose outside. When the level of glucose is moderate, we have a specific active transport, okay? And then classical active transport using the SGLT1 pathway, okay, that will help to go through the epithelial cells to the blood cells, active transport. When we are facing high level of glucose outside, coming from high level of sugar in the diet, but also very fastly digested starch that will create high level of glucose outside, then we have three different pathways. The first one still active, SGLT1 will be active, but we will have a facilitated diffusion, GLUT2, okay, helping to the glucose to go through. And we also have, on the side of epithelium cells, we'll have paracellular transport, just also helping to, let's say, reduce pressure of glucose outside of the epithelium cells to the blood vessels. So in this case, we have three different pathways. And we also have, and that's something to take into account, we have an impact on the gut microbiota, globally speaking, as a control on the sugar absorption. What does it mean? Depending on epithelium cells and the impact of short-chain fatty acid, mostly, but not only, and then we will be able to activate different pathways. And the release and absorption and release of sugar and glucose will be different depending on diversity and, let's say, dysbiosis, for example, inside this microbiota. So the gut microbiota has a control on the sugar absorption. Then, saying this, what's happened when it comes to the blood glucose concentration? So we have the let's say absorption, digestion of the component coming from the starch, oligosaccharide, directly sugar. So we have the glucose that will be able to go into the blood flow. Here we have what we call the glycemia, so the concentration of the glucose in the blood. And we have a fascinating regulation system based on the insulin and glucagon hormones that are able to make an orientation of what will happen to this glucose. And depending on the concentration of the glucose in the blood, in let's say a sensitive animal, then the insulin will help to improve, for example, the storage of the glucose inside muscle, inside the liver, creating those reserves that can also be fat reserves, and then decreasing the concentration of the glucose into the blood. Okay, so this kind of regulation is very important in order to have the right usage or storage of the glucose. Okay, and globally speaking, so we already can see that we have on this glucose metabolism regulation, we have many, let's say, fraction of usage of those glucose utilization. And at the end, coming back to what we say at the beginning of this session, depending on your choices in starch quality, starch treatment, we may have, looking at the glycemia that will be induced due to your diet profile, we may have a different impact of your diet on the glucose content of the blood, depending on your choices. Two extreme examples here on the screen. An hyperglycemic diet will lead after a meal to a very fast increase in the glucose content. Okay, so in this case, we can speak about hyperglycemia that will of course lead to fat deposition, but also improving inflammation. And the green one, a more moderate one, okay, with a lowest impact on the glucose concentration of the blood first, but maybe a longer release, okay, that will have a different impact on the animal. And this different in the shape of the glucose content depending on time will act on behavior, will act on satiety, but will also act on the way that the glucose will be used for deposition inside the animal. Okay, and if we make a comparison, a fast comparison, for example, between those digestible carbohydrates kinetic of digestion compared to classical, let's say, amino acid digestion, much slower, usually much slower in the time. If we have a fast release of glucose but a slow release of amino acid, of course we are not able to speak about synchronization of glucose and amino acid. We are not facing an optimization in this synchronization. And it's our job to try to find a solution in the strategy in order to make more amino acid facing glucose, good glucose content in the blood in order to improve the muscle synthesis. Okay, so that's one of our target in the, let's say, kinetic of absorption of our digestible carbohydrates. Okay, and we spoke about the glycemia, but of course the related curves in insulinemia is the same, and we have a direct impact on this insulin stimulation on the muscle synthesis. And depending on, again, the curves in the amino acid absorption compared to the glucose, let's say, absorption, the muscle synthesis, the muscle deposit will be affected. And usually when we are thinking about digestive carbohydrates, starch, sugar, we don't make directly the link to the gut microbiota. And we have more and more evidence showing that the gut microbiota is also involved in the glycemic response. And we have, and it's proven now, we have three main factors that will influence the regulation of the glycemia. So in one side, we have the production of the glucose coming from sugar, again, or starches strategy. But in the other hand, we have what will be facilitated or not coming from the state of the gut microbiota. Okay, the first factor will be related to increasing secretion. Okay, that will modify let's say modify the differentiation. That will also be related to the enteroendocrine cells. The second one will be related to, let's say, the gut microbiota metabolism and production that can be translated in the short chain fatty acid production. Depending on this, the glucose transportation will be modified or not. The epithelium cell shape will be modified depending on those, let's say, production, and directly it will modify the glucose absorption. The third factor is related to bile acid metabolism. That's also something completely related to what will happen with the bile acid and the gut microbiota. That will also impact some secretion that will modify the glycemic response. Okay, and if this gut microbiota is not controlled, if we are facing some dysbiosis, then coming from some specific production of this unbalanced gut microbiota, we also may create some bad condition for the glycemic regulation. Okay, and because of this, you will not have the expected impact on the glucose content, on the glycemic response, because your gut microbiota is not balanced enough. At the end, and sometimes we saw it for sows, we have some insulin resistance. What happened in this case? So the insulin is really the hormone in the center of this regulation of ingestion of nutrient, directly related to carbohydrate digestion and utilization of the glucose. As soon as we are facing insulin resistance, that means that the animal will not respond to what the pancreas will produce as insulin, and then the glucose will not be able to be stored the same way. It will not be able to enter the cells the same way. What does it mean? we will have a global impact on hormonal efficiency, on the fat deposition, but also health sensitivity and feed efficiency. So if we are not controlling the global, let's say, mechanism of glucose, let's say, concentration, glucose metabolism, and at the end, the insulin sensibility, we may influence the productive capacity of our animal. As a take-home messages, so less than 1 hour, we went fast through this digestible carbohydrates family. First, they are very important in swine nutrition. They are central. They are not that easy to manage. And especially when it comes to immature animal, we really need to control and to have a targeted strategy in order to control as much as possible that is coming to this physiological nutrition bring by carbohydrates. The kinetic of digestion is something important. We can control it depending on your formulation profile. So what is the total sugar quantity? What is the sugar quality? What is the starch quantity, but what it's come from? What is the amylose-amylopectin ratio in my diet? Coming to my factory and the technological impact. What is or what are my particle size strategy? What is a gelatinization process for one raw material for the global diet? What is my strategy and what will be the impact? And the last but not the least, how to control this gut microbiota in order to give and to keep this, let's say, control in the glycemia. Okay. Then, when we play on this composition and this impact, we will be able to regulate glucose absorption and global metabolism. Really don't forget, and that's one important message, is the gut microbiota diversity, composition and regulation will play and interplace with glycemic regulation. It is not something separated. It's really in a relation. And in an extreme situation, as soon as we are facing a disorder in glycemia regulation, and we spoke about insulin resistance, then a lot of trouble will appear on the animal, and that's obviously not what we are looking for. Many thanks, and see you in a coming session. Thank you.